Hello, my friends. Today I want to share with you a new interpretation of quantum mechanics. And I know that my critics will be very annoyed, especially the physicists who think I'm encroaching on their territory. I have not trained in physics, nor am I an expert in mathematics. And of course, many biologists will also be critical because of my stance on quantum mechanical body biologically, and also quantum healing as the return to homeostasis, to fundamental awareness, pure awareness, without the fluctuations of consciousness. Nevertheless, here's a new theory, and I will call it the unified theory of reality. And also, I will call it, let's call it the observer-observed entanglement in quantum mechanics, the new theory, observer-observed entanglement. So before I tell you what the theory is, I went on ChatGPT and another AI, and I asked the question, what is the measurement problem? Here's the answer. The measurement problem in quantum mechanics is the challenge of understanding how and why the act of measurement or observation in quantum theory causes a wave function to collapse into a definite state. According to quantum mechanics, particles do not have definite properties until they're measured and instead exist in a superposition of all possible states. However, when a measurement is made, the wave function collapses to a single state and the particle takes on a definite value for the measured property. The measurement problem arises because it is not clear how this collapse occurs or why a particular outcome is obtained rather than any of the other possible outcomes. The standard interpretation of quantum mechanics, the Copenhagen interpretation, posits that the wave function collapses randomly with the probabilities of different outcomes determined by the wave function itself. However, this interpretation has been criticized for being incomplete, and several alternative interpretations have been proposed. These include the many worlds interpretation, which suggests that all possible outcomes of a measurement actually occur in different parallel universes, and the objective collapse theories, which propose that the collapse is a real physical process caused by a nonlinear modification to the Schrödinger equation. The measurement problem remains an active area of research and debate in quantum theory, and it is important for understanding the fundamental nature of the physical world. Then I also asked the same AI, are probability waves physical? The probability waves of quantum mechanics. Here's the answer I got from AI. Probability waves, also known as wave functions in quantum mechanics, are not considered physical objects in the traditional sense. They are mathematical descriptions of the probabilities of finding a particle or system in a certain state or location. The wave function is represented by a complex valued function that contains all the information about the system, including its energy, momentum, position, and I would add spin. However, the wave function itself cannot be directly observed or measured. Instead, it is used to calculate the probabilities of different outcomes of measurements. In other words, the wave function is a tool used to make predictions about the behavior of particles or systems at the quantum level, but it is not a physical object that can be directly observed or measured. Okay, so much for AI. It's obvious that AI doesn't have any original thinking at all. It goes with the prevailing discussion. It's a sophisticated algorithm as far as I can tell. So here is the solution, my friends. The embodied observer and that which is observed are entangled in superposition before the measurement is made. And before the measurement is made, they're both in the field of infinite possibilities or non-local correlation or entanglement or whatever you want to call that, okay, in the singularity. And then as soon as there's an intention to measure and an apparatus to measure, which is an extension of the embodied observer, then what happens is that the observer and the observed split, which is, by the way, the basis of modern science, is that the observer and the observed are separate entities. Also, current physical sciences assume that matter is the ontological primitive. And so there are many problems with that. Matter is the ontological primitive. The wave function is not material. Only the particle appears as material, but the particle itself is a space-time experience in awareness, as is the embodied observer. Both are quantum mechanical in nature. Everything is quantum mechanical in nature, the whole universe. Macro objects are also quantum mechanical in nature. So actually, there is no problem here. The only reality is non-local, period. And locality appears when there's a perceptual experience. To be physical with a split, observer and observed. But this embodied observer is also the result of the collapse of the wave function. And that particle which is observed is also a collapse of the wave function. And neither of them are material objects. They are not only quantum mechanical objects, they're not objects at all. They are the moving wave function. Okay. And the particle is an interpretation at the moment of measurement, but there's no particle. There's only the wave function. And at the deepest reality, that wave function exists non-locally at all times until observation is made. But the observation is not made by the embodied observer. The embodied observer is also part of the observation. So there's no physical entity, engagement problem. They are both entangled, the embodied observer and that which is observed, in superposition at all times in timeless, non-local awareness. I'd love to have some comments from physicists and biologists on this. Thank you.